Hello everyone, welcome to SimpliCode's YouTube channel. I hope you guys are doing good and staying safe. In today's session, we'll discuss another important data structure which is linked list. Linked list is considered as one of the most fundamental data structures. Now, although linked list and arrays are similar since they both store collections of data, array is the most common data structure used to store collections of data in a continuous locations. They're convenient to declare and provide the easy syntax to access any element by its index number. But there are some drawbacks for arrays as well. Since they have a fixed size numbers, we cannot insert new data at a real time. Now, linked lists have their own strengths and weaknesses as well, but they happen to be stronger where arrays are weaker. Now, generally, arrays allocate the memory for all its elements in one block, whereas single linked list or linked list entirely has a different strategy. Linked list allocate memory for each element separately and only when necessary. So we will be discussing all about linked list, why they are used, how we can perform various operations on linked list in this tutorial. But before we begin, if you're new to the channel and haven't subscribed already, consider getting subscribed to our channel SimpliCode to stay updated with all the latest tech content. And hit that bell icon to never miss an update from us. So without any further ado, let's get started with today's topic. Firstly, let us discuss the agenda for today's session. We'll start this tutorial with a quick introduction to what are linked lists, and then we'll understand why we use linked list. After that, we will discuss how does linked list work, and once we are done with all these basic concepts, we will try to perform some operations in linked list, and finally we'll conclude the session by understanding some of the advantages and disadvantages of linked list. I hope I made myself clear with the agenda, so let's get started. So firstly, what is a linked list? Now, a linked list is a data structure that is used to store a sequence of elements such as integers or objects. In a linked list, each element is called a node and is linked to the next node in the sequence, where each node contains a value and a reference or pointer to the next node in the sequence. Now, you can see the diagram here. Each node in a linked list contains two things, that is the data that it represents and a pointer to the next node in the sequence, that is it stores the address of the next node. So the first node in the sequence is called the head of the list, and the last node in the sequence has a null pointer at its end. So in linked list, data items in the linked list are not in consecutive memory locations, unlike the arrays. So in order to add an element to a linked list, you create a new node, sets its data to the value you want to add, and set its next pointer to the current head of the list. And then you finally set the head of the list to the new node. So let's just understand with the diagram here. So we have a head and we have 4 different elements that we are using, 4 nodes, each consisting of a data part and address part stored at some address. So in a linked list, we have a special node called the head node, as we discussed earlier, that holds the address of the first node, which has a data and has the pointer, that is the address of the next node. So each node is in a linked list connects with the other through a pointer that points to the address of the next node. So whenever we add an element to a linked list, we create a new node and link it to the last node in the sequence. So each node in a linked list connects with the other through a pointer that points to the address of the next node, and arrows in the above given diagram represent that the same manner. So in a linked list, each node connects through a pointer that points to the address of its next node. So in order to traverse a linked list, we also start at the head node and follow the pointers to the next node until we reach the end of the list. So this is how the linked list works in a nutshell. So next, let us discuss why we use linked list. Now, the first obvious reason is to overcome limitations of arrays by providing dynamic size. Now, linked list can grow or shrink dynamically as elements can be added or removed, which means that we don't need to know the exact size of the collection in advance. So this makes linked list a good choice for situation where the size of the collection may change frequently or is not known in advance. Efficient insertion and deletion. Now, linked lists provide efficient insertion and deletion of elements, especially when working with large collections. So in order to insert or delete an element, we simply update the pointers in the surrounding nodes to point to the new location of the element every time it is inserted. So without the need to shift any other elements here and there. Memory efficiency. Linked lists use memory more efficiently than arrays, as they only use memory for the actual elements and the pointers to the next node. Whereas if you take arrays, it needs to allocate continuous memory for all the elements regardless of whether they are used or not. And finally, flexibility and versatility. Now, linked lists come in different forms, such as a single linked list, double linked list, circular linked list, each with its own advantages and uses. This makes linked list a flexible and adaptable choice for different programming scenarios. And they can be considered a versatile data structure because they are used to implement various other data structures such as stacks, queues, uh, and other important data structures in also various algorithms for efficient memory usage and data management. So let us understand the syntax of linked list. So if you take any programming languages like C or C++, linked list can be implemented using a structure and a pointer. So if you look at the syntax, the syntax is struct, which is the keyword for structure, and then we are creating a node, and inside the function main, we are writing int data node, and we are creating a pointer. So the above definition is used to create every node in the list, and the data field stores the element, and the next is a pointer to store the address of the next node. So if you notice here, in place of a data type, we are using struct node, which is returned before the next, right? Because it's a self-referencing pointer. It means a pointer that points to whatever it is a part of. So here next is a part of a node and it will point to the next node. So let us now discuss some of the operations in linked list. Now there are three important operations we can perform, which is traversal operation, insertion operation, and deletion operation. Now, when I say traversal, traversing means accessing each and every element of a data structure at least once. Now, linked list traversal means accessing all the elements of the list starting from the head node to the last node. And we have other operations like insertion and deletion, wherein we can have a different types of insertion operation and deletion operation. So insertion can be done at the beginning of the node, wherein we are trying to insert a new element at the beginning of a linked list, and we can even insert a new element at the end, and we can even insert a specific node in between of a linked list. And similarly, we can perform the similar deletion operations at the beginning, at the end, and even at a specific node. So let us now directly jump into Visual Studio Code, and let us try to understand how linked it works with some examples with its syntax. So as you can see, Visual Studio Code has started. Now before we move ahead and discuss some of the operations on linked lists like traversal, insertion, deletion, searching, and sorting, let's just create a simple linked list so that you will get a clear understanding on how it will actually work. So let's just create a simple linked list here first. So the code would be include the header files first, hashtag include iostream, using namespace std, and then we will create a structure named node. Okay, so inside that I'm declaring integer and data and a pointer of the node which contains the address of the next node. Okay, so in this first line, we are basically creating a structure. The structure node forms the linked list node here, which contains the data and a pointer to the next linked list node, which is the next which we have created here. So next, let us move ahead and create the syntax, that is the basic function on how linked list works. So for that, let's just go to the next line. And next I'm creating a structure node, and it has the pointer. I'm giving pointer to the head, which is first I'm equating it to null. Next I'm trying to insert some values. Okay, I'm passing an argument, which is I'm taking a function here insert, and I'm passing an argument int new data. And open the brackets. Now struct node, give the pointer, new node which you have created, is equals to the struct node. Now I'll explain why we are taking this, guys. So let's just understand the code first here. So basically the insert, which we are trying here, trying to insert values, places the data at the beginning of the linked list. So it creates a new node and inserts the number into the new node's data field. Then the new node points to the head, and finally the head is the new node from which the linked list begins. So I hope you've understood what it is. So now we have to allocate a size for this linked list. So for that, we will be using a malloc function, which is again a memory allocation, which dynamically allocates data. Now, what actually happens is if you don't use malloc, your compiler starts using random memory space from your computer RAM. So it is important that we use malloc function here. So that is why we will use malloc function to initiate or to allocate data for our linked list. So I am taking malloc, and the syntax is basically this size of, we're just giving the size for it, that is it will actually allocate data to the node which you have taken. So close the brackets, and next we have to write the algorithm for that, how the data product the flows within the linked list here. So the new node, I'm pointing it to the data, so I'm using the pointer operator here, and I'm setting it as new data. Now this new data will become the address of the next node, so it points to the next node. So the new data points to the next, and it will save the data, and it will become the head, that is the first data. Now head becomes the new node as we discussed earlier. Okay, head is equals to new node. So that's it. Now we have to display all this which we have taken, that is we have passed an argument to a function, right? So we have to display it. So for that I am taking another function, void display, and inside that struct node, give the pointer, which is, let's say, let's take PDR. Now this pointer will point to the head of the node, that is the first node in the linked list. Now give the condition, while pointer is not equals to null, we will basically print the data. So while pointer is not equals to null, we are basically printing the values. Okay, right. So see out, mention the pointer and print the data. Right, and next we will assign this pointer, which will point to the next node. So pointer equals to pointer pointing to the next node, that is the next node that we are trying to point. So close this bracket. Now we are good to go. Now all we have to do is basically insert some values into it. So I hope you understood what we have done so far, guys. So we are just inserting some data while creating a new node and inserting the numbers into the new node's data. Now this entire linked list is being displayed by the display function we have taken. So initial pointer indicates the head. After that, it is passed on continuously to following node until all the node's data values are printed. Now we are done, left with the final segment, which is basically inserting data. So create a main function and then insert some values into it. So I'm just using the insert function. Let's say insert 7. Next, let's take insert 17, insert 32, next take insert 56. So I think 5 elements are fine, so let's just take another one, 878. Alright, Now we'll actually print this again. So I'm using cout. So it will basically be the linked list elements are. The linked list elements are. Okay. And I'm again calling the display function so that in order to retrieve all the values. And finally return 0 if there is no values to return, it will directly return 0 to us. So alright guys, this is the simple program which we are using to create a linked list. So let us now execute this and see what is the output. So it will just take some time to execute the statements. So let's just wait for it and we'll see the output. So as you can see, our output, the linked list is 78, 56, 32, 17 and 7. So these are the elements that we have taken. Now you might have gotten a doubt that why the order is in the reverse manner, since we have firstly inserted 7, 17, 32, 56, 78. Now what linked list does is it will basically forward each and every element until the last element that we're trying to insert into it. So basically if you try to insert the first element, it will basically push and it will allocate to the next one. So once I'm starting to insert 7, it will be at the head node, and then I'm trying to adding 17. So 7 will become the second element and at the second node, and 17 will become at the first, and similarly it will so on push until we insert the last element, which is 78. So that is the reason the linked list order is 78, 56, 32, 17 and 7. So I hope you understood this, guys. So let us now create another program wherein we'll try to perform some traversal operations. We'll try to insert some elements in our node in the linked list at the beginning, at the specific node at the end, and we'll also try to delete some of the elements, and we'll try to see the output for that. So let's just clear this space and we'll write the code for it. So again, include. So what we are trying here is we are basically performing some traversal, insertion and deletion of linked list. Okay, so let's get started with that. So let's include the header file iostream using namespace std. Now it takes a lot of time, guys, if we try to execute each and every program. Like for insert operations, we have 3 different ways, that is at the beginning, at the specific node and at the end, and similarly for deletion also. So I'm trying to cover all this in a single program, so make sure you stick to the code here, and even if you have any doubts, you can let us know in the comments and we'll try to resolve them as soon as possible. So try to understand what we're trying to do here so that you'll get a clear understanding, and we'll also leave the code in the description so you can check that out as well. So firstly we have to create a node. So let's just take the similar one which you've taken earlier, which is struct node, and inside that we are creating a data, int data, and then we are creating a pointer to the node which points to the next node in the linked list. So node. So make sure the names are in the exact similar same way, guys. So since we have taken capital N, it should be capital N here as well. Otherwise, it will throw an error. So make sure you be careful when you are declaring variables. Otherwise, it will throw an error eventually. Now we are creating a function. Let's take a insert function. We are trying to insert some values at the beginning of the linked list. So I'm creating a function. Let's take let's say insert at beginning, which is a function name, and inside that I'm passing an argument where we are trying to get the address of the head node. So struct node, use the pointer and give the head reference and int new data. So the new data is we're trying to each and every time you add data to the linked list, it will be the new data here. So these are the 3 arguments that I have passed. So let us now allocate memory to our node. So for that I'll use the malloc operation. So struct node, which is the new node we have created, equals to struct node pointer. Now allocate the size. So this is basically the syntax of malloc function, guys. So there's nothing complex of it. Just follow this what we are doing here. Size of, and mention the node, which is the structure. All right. I hope you have clearly understood till here what we have done. So let us now try to insert the data into our nodes. So for that, we have taken a new node, right? So it will basically point to the data we are inserting, and it will save into the new data. All right. Next, this new data, this new node will point to the next pointer until we are trying to print each and every element into our linked list. So new node points to the next. Once we insert a element, then we are giving the next as our next element where we are trying to insert, and I'm giving the head reference that we have taken earlier. So now once you have created the head node, you have to move this head to a new node. All right. So for that, the code would be head ref is equals to new node. Sorry, underscore ref equals to new node. So we're basically trying to pass the head node, since once if an element is inserted into a head node, and we are passing it to the new node here. So it will directly save the location it's in this position. Next, we have to insert a node after a node. That is, let's take a linked list. If you have a 5 elements, so in that case you have to keep adding, right? So in that case you have to keep adding a node after node. So for that, what I'm taking is I'm creating another function here. Let's take insert after, and again inside that I'm declaring the structure node. Next, previous node, and then we have the new data. So new data is basically the one which you're trying to add, and it is being added into the previous node simultaneously. Now you have to give the condition. So the loop you have to run, right? So for that, what is the condition? What the condition would be? So for that, I'm using an if operator where if previous code is null, then the given previous node cannot be added into the next node. So I'm just giving a statement here which will give the compiler that if the previous node is equals to null, the given previous node cannot be a null value. So prev node is equals to null. So see out, we'll get a warning or a message that the given, let's say, given previous node is a null value. So it shouldn't have null values, but so for that we are trying to give this a statement here, and then we will basically return 0 if there is a null value. So all right, this is also done. So moving next, next we have to basically allocate memory for each of the nodes or the elements that are being added, that is for the previous node into the new node. So for that, again I am declaring the struct here, struct node, new node. Now just understand the logic here. New node is equals to struct node, and I'm giving using the malloc again allocation for giving size for it, size of struct node. Okay, so basically the new node which you are creating here, it will point to the data first, and it will store into the new data itself. Okay, then what happens is this new node, okay, will point to the next node. That is, new node points to the next, and it will save to the previous node. That is, this is taking the data from the previous node and again pointing it to the next node. So priv node, we're taking a pointer which is pointing to the next node here. And we have to finally save the value for this previous node. So priv node pointing to the next node is equals to the new value. All right. So let's say I have three elements, that is 7, 8, 9. So first we have inserted this 7, that is the new node, and I'm giving a data which is 7 and it is storing into the new data. Now new data, new node. Now if you're trying to insert a new element, that is 8, so it will point to the next. So this 8 will have the address of the 7th, that is the previous node that you have created. So that is why we are creating previous node points to the next. So similarly, it will also point to the 9th. If you take another data which is 9, it will point to the next node. So this is how you can create a node after a node. So next, let us try to insert some elements at the end. Now we have created at the, I think we have created at the beginning here. So let's just try to create some elements at the end. So guys, now it will take a lot of time if we keep writing the whole code. So in order to save time, I've copy pasted this in the notepad and we will try to understand here itself and we'll execute it directly. Now we have created till here, which is insert a node after a node. Next, we'll try to insert an element at the end. So basically what we're doing here is we are allocating memory for a new node. Now the syntax remains same. We're just creating a function insert at end and we are passing the arguments and we're trying to store data and trying to traverse to the last node. So once the elements are added, you need to change the next of the last node to recently created node. So for that, what I'm doing is I'm just creating a new node, pointing it to the data, new node, and new node again pointing it to the next. If the head reference becomes null, and we are assigning it to the new node. So again, you can see here we have another statement which is while if the last element is pointing to the next, and if it is not equals to null, then last will become the next element of that node, and finally we are returning that value. So let us now discuss this part of the code where we're trying to delete a node. Now it can be deleting from the beginning, and it can be from end, it can be from anywhere else. So we are just creating again a function delete node. We are pointing head to the second node here. So if we are just creating a temporary variable here because we are trying to delete it. So if temp is equals to null and temp data is equals to the value that is we are trying to delete, it will save the head reference to the temp and it will point to the next. And finally, next we have to find the key that needs to be deleted. So for that, I'm giving another while loop here. While temp not equals to null and temp data is equals to key, it will store the previous to the temporary value and temp will point to the next value in that node. And again, I'm just giving another condition here, that is if temp is equals to null, we are returning that value. And finally, we are trying to search an element on a linked list. So you can search an element on a linked list using a loop using the following steps here. Basically, what we are trying to do is we are making head as the current node. So let's just giving this statement while current is not equals to null, and if current is equals to the data that we are trying to point, it will return false. So run a loop until the current node is null because the last element will basically point to the null. So in each iteration, you have to check if the key of that node is equals to the element that we're trying to find. So if the key matches the element that we're trying to find, it will return true or otherwise false. So that is what I have done here. So if you look at here, return else statements, which will try to return if the values is equals to the element that we're trying to find for. And next we are trying to print the linked list. So for that, I'm creating another function here, guys, which is print list. And after that, we are passing the arguments again, and I'm giving the initial declaration where if the node is not equals to null, then we have to print that the node will point to the data, and the data that is stored in that node will point to the next, that is the address of the next node. And finally, we are into the main function where we are trying to add the data or trying to insert the data for the functions that we have created. So I have created, since we have created various different functions, right, for inserted in, which is used to insert values at the end of the linked list, and it is pointing to the address of the head. So and the value is 24 here, and then similarly we are inserting some values at beginning, in end, and after a particular at a specific position, so that the values are 24, 3, 36, 49, and 54. Now let's, I am printing the linked list. So for that, the linked list elements are anything, you can keep it your wish. I'm just keeping the linked list elements are. And then we are performing, since we have also performed the deletion operation, so after deleting an element, we are trying to delete the element which is 3 here. Since we have an element here 3, we are trying to delete it. And then we are trying to find if the item is, if the element is deleted or not. So for that, I'm taking int item to find is 3, and it will perform a search operation on that. And if the element 3 is found, I'll basically retrieve the value, that is by stating item to find, which is 3. If it is found, I'm declaring it as found, and if it is not retrieved or it is not found, I'm basically mentioning is not found. And finally, we are retrieving the values again by passing the arguments again here, and we are storing the address of the head value. And finally, the sorted list, we are also performing the sort operations, right? So for that, I am giving the declaration for that as well. So the sorted list after deleting, okay, after deletion would be this. And finally, we are printing the values that we have taken. So this is the code, guys. I know this is a bit longer. It will take almost the same time if I try and explain each and every concept of insertion at beginning, in the middle, at the specific node, and similarly for deletion. So instead of that, I'm just creating a single program. We will also share this in a document file so that if you have any queries, you can go through it. And if you have any further doubts regarding that also, let us know in the comments, and we'll try to explain it to you, what is the process or the thought process of what the code and actually what we have done there. So let's just copy this and let us try to execute this in our Visual Studio Code. So let's just copy paste this. So let us execute this. It will take some time. So let's see. As you can see, the output, the linked list elements are 36, 3, 54, 24, 49. Now 36 is we have inserted at beginning, and we also have another element which is 3. So that will push to the next second element. And next we also have 54, which is after, that is a particular a specific node we are trying to insert, that is after the element 3. And next we have 24. 24 is at the end, right? And similarly we have another 49. So first we have the 24 and then 49. So we also deleted an element which is 3, right? So after deleting an element, now the linked list becomes 36, 54, 24, and 49. Now again, I am asking the compiler whether the element 3 is deleted or not. So it is saying 3 is not found. And finally, we are performing a sort operation where the sorted list after deletion becomes 24, 36, 49, and 54. So this is how you can perform insertion, deletion, sorting, and traversal. Now traversal we haven't discussed, but it is similar to this only, which will basically try to find each and element from the head to the tail node of the linked list. So I think we have pretty much discussed everything about linked list, guys. Thank you for watching the video, guys. If you found this tutorial informative and helpful, give it a thumbs up and share it with your friends and colleagues. If you have any further queries regarding any of the topics covered in today's session, feel free to let us know in the comment section below, and a team of experts will be more than happy to help resolve all your queries at the earliest. Stay tuned to the channel for more such amazing content. We will be covering another important data structure in our next tutorial. So make sure you stay tuned that. And if you want to know more about data structures, we have a dedicated playlist where we have discussed the basic introduction to data structures. We have also discussed what are arrays, structures, pointers. So you can check that out as well. We'll leave the link in the description below.